Thank you so much. May I now request the founder and CEO of Talent Sprint, Dr. Santanu Paul, to please grace the dais and give us some keynotes about the speaking. He is a visionary leader and an entrepreneur who has revolutionized the way individuals and organizations approach talent development. He established Talent Sprint, a global platform for deep tech education and high-ending coding boot camps, which has garnered investments from prominent players like Nexus Venture Partners, the National Skill Development Corporation, and the National Stock Exchange Group. Under his leadership, the Talent Sprint was honored as a training partner of the year at the prestigious Pega World Inspire event held in Las Vegas. Before Talent Sprint, Sanatanu has held senior leadership positions in leading technology companies. He served as a senior vice president and a global directory operations for Virtusa Corporations. He also led CTO positions at Open Pages and Viveka Inc., both Boston-based tech firms backed by notable venture capital firms like Matrix Partners and Sigma Partners. His diverse and impactful career reflects his passion for innovation, talent development, and driving positive energy change in the technology landscape. Sir, your address to the guests here would be highly impeccable. Just on that note, I'm very honored to say that I'm working for Virtusa now, and it's very good to see the name there. Over to you, sir.
Yes. Thank you very much, Madhu, for this opportunity and the rest of the team that invited me here. When Madhu called me, I think a month ago, said, you should do this keynote. I asked him, I'm not a testing person. But then he said, it doesn't really matter. We want you to make people think. So he gave me an interesting challenge. And my task today is to live up to the challenge of seeing if I can make you think. Of course, I'm trained as a software architect. So in some sense, while I'm not a testing professional, I'm certainly highly interested in quality. And I think one of the major things I spent a lot of my life, especially a technologist in my pre-entrepreneurial incarnation, was to really worry about software quality in a very, very deep and great way. So today I thought I'll, sort of get going on a topic which, many of you here may or may not know, but how many of you know what a cyborg is? No? Take a shot. Okay. Terminator, T-800. Huh? Yes. Okay. So if I take that, what Lakshmi is saying, that it's human combined with technology, machines, electronics, and all of that, right? Is that okay? So we'll start with that, right? So let's begin with this idea that we're going to talk about cyborgs. And the way I'm going to talk about this presentation is going to break it up into three parts. The world of cyborgs, a world of escalating software complexity, which I'm sure all of us are very familiar with. And then finally, what are the characteristics of a new age quality engineer? And what is our fundamental principles of new age quality engineering? So those are three parts that I'm going to get into. So let's start with the world of cyborgs, right? I think we just started with Terminator, so I'm right there. We have Terminator, so good, well done. So you have Darth Vader from Star Wars. People remember Darth Vader from Star Wars? Yeah? Okay, very good. So what was Darth Vader? He was basically a cybernetic augmentation. He used to be a real person, but then became over time infused with technology, with various accidents and other kinds of infusions, got cybernetic arms and legs, which means that it became a part machine, part human. So that's Darth Vader in popular, sort of entertainment fiction. Then you have Terminator, T-800, popularly played by Arnold Schwarzenegger in all the movies and Terminator series. And here, the whole idea is that it's doing good. Initially begins off with this idea that, it's all machines and humans fused to do damage. But really what this is, if you think about how it is described, is that Terminator is like an endoskeleton, means the inside of the body is machines, but the outside is humans, flesh and blood. So you have, again, an example of a human-machine integration that's doing things in the real world. Where the boundaries between technology and human is not very clear, as the lines will blur, in all of us. The whole idea is that we are going to essentially be in an age of cyborgs where humans and machines are going to have a very sort of blurred boundary between the two entities. The third, of course, is Tony Stark in the Iron Man, and this is the Marvel series. And here, Tony Stark is the character, says that, and is played by Robert Downey Jr., who's a very famous and popular movie actor. I'm sure many of you have seen his movies. Tony Stark says that the brain and the spine that I have is human, the rest of me is machines. Correct? So the most important part of who we are is our ability to think, our intellectual ability. So the brain and the spine is human, the rest of it is machine. Again, a human-machine interaction. So that's the real life, as we say in entertainment. But let's look at the real life world, right? In real life too, things have begun to happen. It is no longer just a fiction, the world of fiction that we are in. We are in the world of reality. So let's start with Stephen Hawking. People have seen Stephen Hawking? Yes? After he had this disease called Lou Gehrig's disease, or ALS, in his childhood, in his college days, he essentially became dependent upon computers in his wheelchair to speak, to move, to do everything. And he had a very successful intellectual career. You know, he's one of the most famous physicists of our time. He had a family, he had kids, he had everything. He had a proper life. But essentially, he was a human brain and a very frail body attached to a very complex set of machines, but highly functional, right? Not easy to be a world-class physicist, but the cyborg Stephen Hawking achieved that. Then we have an example of lesser-known people, but this is a very interesting set of people you can Google if you wish. This guy called Neil Harbison essentially got himself implanted with an antenna in his brain. It's actually surgically implanted into his brain. It took a lot of interesting surgeons to do this work for him. And what it does for him, he's an artist. And actually he's, also, I think he's an artist cum musician, but primarily an art, he calls himself cyborg artist. And what he does is he's using the antenna to improve his perception of colors. So if you Google him and read the Wikipedia on this guy, very interesting. He's basically saying that the future of art will be artists who are part human, part machine. And this is a real person. So look it up. And then the final one is a Canadian filmmaker who's mentioned here, Robert Spence. He had an accident, eye injury, could not save the eye. The doctors could not save his right eye. So he kind of lost his eye. So ultimately he had one eye, left eye. But ultimately he had this idea that he's a documentary filmmaker. And when you take a camera and go around, right? For example, a lot of cameras in this room. Typically when you put a camera in front of subjects become self-conscious, right? We become a little careful. We don't say what we want to say. We might be more, sort of stiff. And we have all kinds of problems in front of the camera. So the camera, the documentary maker, the filmmaker, has a disadvantage that you can't capture your subjects in candid if you are basically visible with your machine, right? The camera. So camera is distorting the subject. So he said, why don't I use my right eye, which is damaged, that available socket, let's plant a camera, proper video camera there. And when he walks around, talks to people, essentially he's recording. So he is now no longer, and his eyes are well matched. So essentially what he is, he goes around, talks to people, and essentially his work of documentary filmmaking is continuing because getting source material, of course, with permission. But people are not conscious of the fact that he's recording them because of the way he's using his camera. So anyway, interesting topics to discuss, and I'll let you all go reflect on this a little bit to say that the idea that the humans are going to become surrounded by machines, whether hardware, software, or both, is no longer a very strange idea. It is actually a very natural idea. It's becoming more and more common. All right, so let's move on. Now this, I'm going to take it to the next level, right? I'm going to talk about what is really happening. In China today, firefighters, people who go out and fire department people, professionals, whose job it is to fight fires professionally, they get to wear this firefighting exoskeleton. It is really something like it's like a suit. But when you wear it, you're augmented with all kinds of facilities. One, you can see inside smoke. You can have a physical power that is 2 or 3 times your normal power, so you can move things around, right? You have extra camera power, so you can see through difficult situations. You have the ability to run faster because your legs, the legs of the suit are designed for faster mobility. So all of a sudden you are a super powered or a superman, superhuman, or superwoman firefighter because by wearing the suit. This is an exoskeleton. So the moment you're inside it, your ability as a firefighter just goes up 5x or 10x. Yeah? So now while you're inside the suit, where the human ends, where the machine begins is not very clear. Because now you are embedded, the human is embedded inside this machine that is making you a better firefighter. So this is happening. Nothing new. This is even more interesting. This is happening in Hyderabad as we speak, right? There are surgeons in this city who are using robotic platforms. You might have heard of Da Vinci as a robotic platform, where if you look at this picture, the surgeon's on the left side, correct? So here on the left side, the surgeon is essentially looking into a big console. Her head is buried inside this machine, and she's looking at the patient who's on the other side, on the right side. The cameras are trained on the patient, and the robotic arms are all positioned on the patient, right? The robotic, now you have like dozens of arms in the robotic surgical machine. The surgery is happening, the robotic arms are doing the surgery, but the surgeon is on the left side, essentially working with the robotic arms. So for one practical purpose, you can say that the surgeon's arms are extended into the robotic arms, right? From the perspective of the surgeon, you are now multi-armed, like Goddess Durga, you have 10 arms, let's say. And you're able to do something that you cannot possibly do with your bare hands. In fact, I interviewed one of the surgeons a few years back, and and he said to me, I asked him, like, at what point did you decide to become a robotic-assisted surgeon? He said, the day I realized that I'm getting older, and the day I realized that no matter how good I am, I can never rotate my wrist 180 degrees. Correct? Have you ever tried to rotate your wrist 180 degrees? You can't do it. So surgeons would like to do that, because two things happen when you get surgeons in a robotic platform. Patients have better outcomes because the amount of blood loss, cutting, etc. goes down. But on the other hand, the surgeon also has less stress. Surgeons getting better outcomes because the performance is better and they're getting better results. So it turns out that by using robotic surgery, a surgeon can extend their career by 10 more years. So if a regular surgeon can work for 30, 40 years, because after a certain point your body won't let you, with using machines, you can have an extra 10 years of career, productive career. So all of a sudden, the professional and the subject, the patient in this case, are all benefiting from robotic surgery. So again, an example of a cyborg. My last example of cyborgs, pilot cyborgs. So what is this? Imagine the amount of money it takes to train fighter pilots. Enormous. If you have to have human trainers who are pilots training other pilots to fly, expensive combat aircraft, that's really difficult. So what you want to do is you want to train machines. So today what you have is, when the flights take off, trainee pilots, all the data is being collected by this machine, the computer systems. They're being fed into a simulator, which the simulator you see this particular training pilot. So this pilot has gone off, flown some time, come back. The machine now knows what they have done well, what they have not done well. What they have not done well has turned into training plans. And the simulator is now pushing the pilot to deal with those training plans. Correct? So you built a feedback loop without humans in the loop. The machine is essentially training the pilots, next generation of fighter pilots. So I could go on for many such examples, but I'll stop there as part of the first part for me to convince you, hopefully, that the future that professionals, and I'm talking about professionals, if you are a professional in any field, the idea of augmenting yourself or enhancing yourself using great technology and making the technology an inherent part of your capabilities is actually very good for you, because that's exactly how you become a super professional. That's point one. The question then applies, of course, is does it really apply to quality engineering? We'll see more about that. So let's look at the world of software complexity. What are we dealing with? There are spectacular failures and spectacular successes in quality, right? One failure we all know, the Boeing 737 MAX. You're aware of this problem? Have you seen the documentary in Netflix? Okay. So this was the particular one, the MCA system, essentially caused two major crashes over the last 3-4 years. And this was a new plane that had been rolled out under great hurry because of business pressures. And it had two fatal crashes. Initially, Boeing refused to accept it. And then finally, they had to accept that there was fundamental flaws in the software. And of course, it's not a new problem in quality and testing. We've been seeing this for 50, 60 years, that simple errors can cause life-threatening outcomes. And this was one of them. But the interesting thing is that if you read the article in the print, there's a lot of blame put on Indian software professionals, saying that there are companies that I won't name, 2-3 very well-known companies out of our own community of companies in India, were specifically blamed for producing software that was of poor quality, right? Now, of course, some of this is just pure, people saving their skin, but the point remains that complexity is high when you have these, airplanes, which are essentially nothing but airplanes which are souped up with lots of technology. They're essentially automated to fly under conditions where the pilot doesn't have to get involved. Pilots are incentivized to use the automated flight pilot mode as opposed to manual flight pilot mode for other reasons, like saving fuel, for example. So there are a lot of things that are happening in the world of aviation where It is going to be more automated flying. Pilots are going to be more, Borg-like as we speak. And that also leads to the question of saying that how do we test software or ensure quality of software under such difficult conditions? Another big failure, Tesla's crash a few years back, which led to lawsuits. Tesla finally won the lawsuit. But the idea was that, of course, we know that computer vision has reached a level where it can do a better job of recognizing obstacles in the road than humans, because humans have inherent limitation. There's a 3 to 4% error rate humans will always have in making a judgment. But when you have computers doing it, you do a better job. But finally, when a crash does happen like this, who's liable for it? So there is problems of, moment you get into autonomous driving, we're going to have this problem, right? We have to start worrying about how do we ensure quality in a complex environment. Let me give you some success stories. Chandrayaan, right? After Chandrayaan 2 to Chandrayaan 3, the entire model was changed to say that if you assume that failure is normal, the failure is what is normal and success is an exception, which is highly defensive quality engineering, then they built a model of saying that, okay, what if you assume that anything and everything can fail at any and every time? And you build your entire model of, starting from the architecture, the design, to the entire test plans, you work with this approach that anything and everything will and can fail. So therefore, the success of Chandrayaan 3 to a large extent was because of the enormous number of simulations that were run under enormous number of conditions, well before the flights ever actually took off. So that's a good example where quality engineering has successfully done something that nobody has done before. The last one, which I'll give you an example of, which all of you are familiar with, and I had a 5-year stint with NPCI when UPI was being built. I was part of the board at that time and also heading the Financial Innovation Council that NPCI had set up. UPI, I'm sure all of you use it. Do you like UPI? Okay, why do you like UPI? Yeah, small cash is gone. Small cash transactions are largely gone. So it's a highly efficient system. To give you a bit of a story behind this, in 2016 December, when demonetization was announced, at that time UPI had just come out, had been in the market for a year and a half, and nobody was using it. At that time, wallets were popular, Paytm was everywhere. So I remember we were looking at the numbers in NPCI and we realized that in the month of December 2016, exactly after demonetization, 1 million UPI transactions happened in the country in the month of December, in 1 month, in 30 days. Today, how much is the number? Can anybody guess? Does anybody know? Yes, correct. It's gone to about 3 billion, billion with a B, 3 billion transactions a week. And if all goes well in next 18 months, it'll be 1 billion transactions a day. Yeah? So from 1 million transactions a month to 1 billion transactions a day in 8 years. So the world's, I would say, in terms of acceleration and growth, there can be no better explosive growth than this. And yet, have you heard of major UPI crashes? Have you heard of major UPI outages? Not really. Not really. So one of the reasons for that is, there are many reasons. I'll give you one or two. Horizontal scaling versus vertical scaling was one reason. But the other reason really is that the people who built UPI were big believers in chaos engineering, right? They started bombarding the system day one until date, non-stop. There's a lot more load on UPI that is put synthetically under extreme conditions every day than is actually happening through real transactions. So if the UPI transaction we see, billion transactions a day kind of thing is what is real business, there are probably a whole order of magnitude higher number of bombardment happening on the system, assuming that UPI will break at any time. And the fact that everybody assumed that UPI will break and cannot scale and has to be designed for scale has led to this preventive model where the system is always far ahead in terms of its abilities than whatever demands we are putting on it from the citizen's perspective. Right? So another example. So I would say that these are good examples where quality, Chandrayaan, UPI, we should be all proud. As a country, I think we have come to a point where we're able to build these world-class systems, which worldwide, I would say that in the last 2 years, if the two systems have caught the imagination of the world in terms of Indian engineering, it is Chandrayaan and it's UPI. Worldwide, everybody's trying to figure out how do you deliver such world-class systems at such low cost, right? And one of the principles is frugal engineering, of course. So I won't have time to get into that, so let me move on. Just in the interest of time, I have a few more minutes. So what I'll do now in the last 10 minutes of my talk is try to stitch all this cyborg, scale, issues of scale and the whole software, escalation of software quality problems, complexity problems, to talk about the new age quality engineer. Right? Like I said and I gave a disclaimer in the beginning that I'm not a test professional, so forgive me for saying a few things that may or may not suit our expectations. But fundamentally, I think quality engineering is going through a massive change as a field, and it has to because of the stuff we mentioned. So let's talk about some of these things. Let me start by talking about who's going to be a great quality engineer of the future. Now, historically, my experience, you can contest that view, is that quality engineering has always been seen as a very analytical profession, right? It's a left brain profession. If you look at this model I have in front of you, this is called the Ned Herman's whole brain model, where he talks about the fact that you need 4 parts of your brain to activate well for you to do anything really well in any profession. One is the top left, the so-called analytical brain, where you are logical, analytical, data-driven, logic-driven, and very, very fact and quantitative, fact-based and quantitatively oriented, right? So you're looking everything through the lens of numbers. In our profession, in software, we always respected for looking at spreadsheets, correct? Or at least looking at your bugs databases. So you're always sort of saying that, okay, if you talk through data, talk through numbers, which we always talk about that. So that top left quadrant is very important, and I think it's an area where most quality engineers and test engineers are already very good at it. Then the bottom left, which is organizing yourself, right? Are you good at planning? Are you good at organizing, detailing, putting things in proper timelines, timesheets, project management? Can you get things done on time, right? Can you follow a process? I think that's also left brain, and that also I think we are good at doing. What we are not good at doing, in my view, in our profession, is the right side, where Ned Herman talks about the bottom right, which is the entire relational and the interpersonal aspect of things, right? So having empathy for the customer. I mean, I see that as a challenge today, right? For software professionals, and certainly for software developers and also software test professionals. Empathy for the customer, I think, is not great. And understanding why people use our systems is not very good. We don't spend too much time worrying about empathy for the customer, empathy for the user. And I think that ability to really say that, why are people using my system? In fact, I always have this mantra that I wake up in the morning and ask this question in talent sprints context every day, that why should people buy our products? Why should they use it? Just because we are offering products doesn't mean that people should buy it. What is it that we are offering that people should buy, and why should they do it? So the question that we ask always is that, why should somebody pay for my thing, right? And how much will they pay for it, and why will they pay for it? So therefore, that question we have to ask a lot more, and that requires us to be far more empathetic to our users. So that's this bottom right. And the top right is the experimental intuitive part. Are we taking risks? Are we coming up with new theories, new challenges? Are we able to visualize things in different ways? So the idea that our brain has to be able to come up with new scenarios and looking at new ways of looking at things, challenging ourselves, challenging status quo, challenging our bosses, challenging our peers, I think that is another thing we are not very good at. So long story short, in my view, the quality engineer of the future has to have a robust approach to these 4 dimensions. It's being analytical and being organized and process-oriented is necessary, but not sufficient, especially when the complexity of the world we described in the case of UPI, Chandrayaan, all those examples. I think we are seeing the emergence of professionals who are very, very right-brained. In fact, so right-brained that I want to take you to my next example, where Daniel Pink wrote this book 20 years ago called The Whole New Mind, in which he actually predicted that the way AI is going, 20 years ago he said, the way AI is going, the left brain people will actually struggle as time goes on, because everything you can do analytically is going to be done by algorithms. And anything that you can do through intuition can be done by humans. So if you're a human professional, your best bet is not to lament the automation of our professions, but to improve our intuitions and improve our ability to make right-brained decisions, which goes back to the previous diagram. Relational and experimental abilities. Can we build better relationships? Can we actually experiment and take more risks? If we can do that, then according to this theory of Daniel Pink, we are future-proof as professionals. Otherwise, we are not. If you're going to say that I'm a great spreadsheets person and I'm a great Microsoft project person, good. But at some point, the machines will come for us and they'll overtake us. All right. This is the other part I want to mention. If you really look at the history of, this is the only slide on testing that I've tried to put together because it's not a field that I know very well, but this is my observation of testing as a field. 20 years ago, manual testing was king. The idea was that humans would design good test cases, test scripts, and then humans would test them to death. using armies of people. And there was a profession called manual testing, which made people successful and financially rich. That slowly went away, and then in the last 10 years, we saw the emergence of test automation. People started talking about automated testing. So we don't want to execute tests in an old-fashioned way, right? We will now, humans are trained to produce good test scripts, think about test scenarios, spend some time, very carefully write out those testing scripts, and then give it to machines to execute. And that's how automated testing happened. That's what Selenium became famous, right? You could give it things to automate. So the brawn part of it, the muscle went away because machines took over the muscle part. The brain creative part was kept by humans in automated testing, test automation, automated testing. But I think we're now entering with generative AI and with the rise of ChatGPT and a whole bunch of other similar generative AI software that is coming. I think writing a good test script also is going to be machine-driven, but not entirely machine-driven. Machines will generate plausible test scenarios, and human experts have to oversee them, validate them, correct them, edit them, modify them, make them better, sharpen them, right? So in other words, we are entering a cyborg world where the machine is taking some calls on what to test, and the human is working in a loop with the machine to decide if that is worth testing, and if there's a better way to test it, or there's another way the machine is missing. So machines will make mistakes. Humans, anyway, we know make mistakes. But the beauty is that if humans and machines work together in cyborg fashion, so the future QE professional is, to me, is the cyborg in that sense, that you're surrounded by technology, including generative technologies, which are giving you constantly new ideas of what you can do. And you are able to look through those ideas and actually shape them. And those ideas are not just ideas, they're actually executable test scripts, right? So in this world, where everything around us is changing, generative AI changes the way we look at our profession. If we look at low code, no code, if you can produce code this fast using machines, you have to test code that fast also using machines. And then, of course, I talked about immersive technologies. We talked about chaos engineering. And this all leads to the whole next generation of people are talking about digital immune systems. People are talking about self-healing systems and so forth, where the machines themselves, the software can itself get to the point where it can protect itself from damage and correct itself in the case of errors. That's a whole new subject by itself, which I don't have time to get into. But the whole idea is that if we can look at our profession as we are a combination, if we can go back to my previous one for a minute, the top right, humans provide brains, machines provide brains and brawn. That is the future of autonomous testing, right? And that's where I think we are currently headed for. And that's the part of the world that is a Borg-like world. I'll end with this one slide. And this is somewhat different than what I've been saying so far. People ask, what is quality? It's an age-old question in quality engineering. What exactly do we mean by quality? And many people will say, oh, we know quality when we see it. Some people will say more tactically, it's a lack of, or the fewer the defects, the fewer the errors, the more the quality. All true. But here is an example that I want to give you, right? This comes from a very interesting book called Leela. It's a novel written by Robert Pirsig, who's a very famous writer. You can Google him. He was famous because he wrote a book called Zen and the Art of Motorcycle Maintenance. That made him famous. Big fan? Okay, good. Have you read Leela? Second book? Okay. So go read it. This book essentially makes a very interesting claim. He says that every system in the world, whether it's a physical system, software system, biological system, government system, social system, any system, right? You can think of your government also as a system. You can think of your panchayat as a system. You can think of your sort of municipal corporation as a system. You can think of your software as a system. Your car is also a system. Your watch is also a system. So any system, he says, is always under pressure from two sides. On one side, the pressure is force of continuity. In the case of software business, it's like, oh my God, legacy code. Oh my God, we can't fix it. Oh my God, we've got millions of lines of this code that we have to carry because if you fix something, it'll break. If you break, business will die. Right? So there are forces of continuity which are always putting pressure to say that don't change things because they might break. If you change things too much, you will end up in a bad place. So we come up with process, we come up with quality management, we come up with all kinds of things to protect and preserve what is working. Right? On the other side, there are forces of change. The world is changing, which means the system must be agile, it must adapt, it must constantly keep up with the next set of expectations. It should evolve, it should be programmable, right? Quickly, if my customer wants a change, can I adapt to it? But if I can't, if my system is so solid that it works beautifully now, but I can't change it ever, you know that that's not a system that is very good, right? Intuitively, you know that. But if system is so good at adapting that it keeps breaking every day and crashes on the basic same bugs again and again, that also is not a good thing. So the whole point is that as quality engineers, you can achieve quality when you can build equilibrium in your system. So the forces of continuity and the forces of change are not killing each other. So you build systems which are robust, which can scale, which can really provide repeatable, available good behaviors on the left side, but you also make sure the system can adapt quickly and change at the same time. And a good quality professional's job is to ensure the systems we build are such that we can tackle forces of continuity and forces of change in equal measure without breaking the system.
My question is, sir, you talked about the trends and the technologies which are coming up for the technology professionals. I just wanted to know about the chaos engineering that you talked about. So what is it, and how is it going to impact the IT and maybe industry?
Okay. The whole idea is that, in a very brief terms, if you deal with systems that are going to be exponentially growing, the system like UPI or Aadhaar, right? As taking those examples, but there are many examples like that, which we call now citizen scale systems, not customer scale, not enterprise scale. Enterprise scale is too small when you think about Aadhaar and UPI, right? Because the number of transactions are so, you might have to just get behind the camera. You're probably trying too hard to see me. Yeah. Okay, so in a system which is designed for exponential growth, citizen scale, the idea is that the transaction volume will just escalate so fast that you can't possibly sit and test things in a conventional way. Because if you test for under one set of conditions, it's 1 billion transactions a month, and 2 months later it is 1 billion transactions a week. Your system is just not fundamentally stable enough for you to come to any conclusions. So chaos engineering basically says that you deal with this exponential world with a chaos. You kind of start bombarding the system, anticipating where it will be, right? Not where it is. And therefore, you design the system, so you have a whole, it's like an adversarial approach. You try to break the system at scale as fast as you can, and you hope that you can break your own systems faster than real customers can. That's basically the idea. You unleash chaos on your own system. Yeah. Sure.
Thank you for mentioning some really wonderful books and some very interesting quotes. I think it was one of the most inspiring speeches.
Thank you.
So my question is actually, so you're talking about chaos engineering, and what do you think is the role of synthetic data there? Like what are the strategies that we look at for creating data, which is basically going to drive all these different scenarios that you're talking about? So one of the challenges that we face also as a company is definitely the test data management. So
What's your company do?
So I work for this company called Equifax. So they are the credit monitoring company. And
I've heard of Equifax, yeah.
Oh yeah, I mean we struggle a lot with identifying test data, and we find the legal and compliance issue like by using desensitized production
Yeah.
data. Right? So this is a big challenge that we face.
Yeah.
And is there any thought process that you have about how do we generate synthetic data, or do you have like a process or tools or technology? I mean, generative is like.
I'm not a test professional or a quality professional, so you're asking the wrong guy. But what I can tell you is that intuitively the answer will be, and I'm happy to introduce you some of these people I just mentioned in UPI and others because they are doing this for living, right? But the intuition has to be that you cannot have a human-driven approach to generating synthetic data. It has to be machine-driven, right? It has to be, again, AI synthesized data. You have to have AI trained enough to say that it can just generate test cases and by the millions. It cannot be like somebody going and collecting the information and data and then trying to massage it by hand. So you need to see the systems which are, sort of what we call super scaling systems or citizen scale systems. And then you have to basically have machines, AI machines or machine learning algorithms which can just generate data at a very, very high, scale. So I think it's like cybersecurity. I remember 5 years ago we were discussing that, cybersecurity is going to be huge, which is true. And then said we need a lot of cybersecurity professionals, which we all said is not true. Because you can't have security guards doing cybersecurity kind of a model, right? So if people are attacking you with very, very innovative algorithms, you defend yourself with also very innovative algorithms. So the future of cybersecurity, same argument that I think we're entering a point where it's like how chess developed. How did chess get to this point in AI? Because humans did not up to a point, humans taught machines to play chess. And finally, chess machines got so good, chess machines started playing each other and they got to the next level. And today humans have to learn that game from the chess machines. Right? So I would say that the argument to any question of this sort will be like, okay, we have to just soup up the automation for generating the data.
Right. And another question that I have for you is like, now that you talked about like all this, AI and machine learning taking over testing professions, right? So what are the skill set that the next generation, testing professional, you think should be focusing on? Like, is there like any stream of learning that we should just?
I don't have an answer to that specific answer, but my talk was an attempt to give that answer, to say that it is no longer possible to be a great professional if you don't develop a cyborg-like approach. Right. To say that I'm going to be smarter because I have better technology that I've wrapped myself with. Right. Correct? And I think human intuition will allow us to get to a certain point, but we need just that technology boost, like the fire skeleton examples I gave you, right? So we need technology boosts to get to the next level, to be able to do this. So if you are any profession, not just testing, if a professional thinks that I'm going to get there without being immersive in technology, like a surgeon today is not thinking about doing manual surgery alone. Just as if you are flying a combat aircraft, you cannot just say, I'll fly with my bare hands alone. You have to get into the machine and the machine becomes part of you.
Yeah, absolutely.
So I was trying to make that point.
Yeah, absolutely.
Yeah. Okay. Thank you so much. Otherwise, I'll get you derailed.